This is section 7.2, page 385. Try it yourself 7. We're also going to do example 8. So we're asked to find the critical value and rejection region for a left tail test with alpha is 0.10. So a left tail test means it's going to be one tail. And we're going to use alpha is 0.10. And I don't have the little fish symbol, so I just use the cursive A. And so we're going to actually use table 5. You can use 4, but 5 is a little bit simpler because 5 already has a lot of this stuff done. And we're just going to go down to infinity for the large sample. So let's take a look at table 5. Alpha is 0.10, one tail because it's a left tail. And our left tail is going to be right over here. So we know it's going to be negative z because it's on the left. So that's going to be a negative. So we take a look at here. This is table 5. See, table 5, t distribution. But it gives us the same thing when we use infinity down here at the bottom. So here we've got a one tail test, and at 0.10 we go all the way down to the bottom, we get 1.282. So we're going to have negative 1.282 for our critical value, and our critical region is going to be to the left of that. Let's take a look now at example 8. It asks you to find the critical values and rejection region for a two tail test with alpha is 0.05. So a two tail test, there's 0 here in the middle. We're going to have a positive and a negative to the right and to the left, and we know those are tails. So we're going to have a positive z sub 0 and a negative z sub 0, and they're going to be the same. So we're going to look up in our table 5, alpha is 0.05, a two-tail test, and going down again to infinity. So let's go to our table 5. We've got a two-tail test. Alpha is 0.05, and down to infinity gives us 1.960, or just 1.96. So that's going to be a positive or a negative 1.96. And a lot of times you can write that as just plus or minus 1.96. And this is how it would look in the table. 7.2, page 387, try it yourself, 9. The CEO of the firm claims that the mean workday of the firm's accountants is less than 8.5 hours. A random sample of 35 of the firm's accountants has a mean workday of 8.2 hours with a standard deviation of 0.5 hours. At alpha equals 0.01, test the CEO's claim. So first let's start with what the claim is. And so the firm's CEO claims that it's less than 8.5 hours for the accountant's workday. So the mean, and that's the mean. So mu, we're going to start there, is less than 8.5. And that's going to be the alternate hypothesis. That's going to be, I'm going to label that CL for claim because it doesn't have equality in it. So that's H sub A. So the null hypothesis is going to be the opposite of that. It's still going to be the mu and the 8.5, but this is going to be greater than or equal to, which is the opposite. And so what we're going to do here is we're going to find our critical value and our critical region. So let's draw our curve. And since this is a less than, we always go by the alternate hypothesis. So it's going to be a left tail test. It's going to be a negative critical value, a negative value over here. So let's start with that. Let's find our critical value. And we've got an alpha of 0.01. And now this is a large sample because n is 35. So that's going to be a large sample. So we get to go down to infinity. And then we'll come back to all this other stuff. So let's get our critical value here. Alpha is 0.01, and it's a large sample. And that's going to be a one-tail test because it's left tail. So that's a one-tail test. And I'm going to use table 5. One-tail test. Alpha is 0.01, and so we're going to go all the way down to the bottom. That's going to give us 2.326, but remember ours is negative. So it's going to be 2.326 on the negative side. The next thing we want to do is we want to find the z value. So what else do we need first? Well, we need for our formula, for our z formula, we're going to need x bar and mu. We're also going to need sigma and divide by the square root of n. That's our z formula. So we're going to need our x bar. Well, in here we've got a sample of 35, so that's our n. Found a mean workday of 8.2. That's going to be our sample mean, which is x bar. So that's going to be 8.2. And the standard deviation is 0.5. Well, that's our sample standard deviation of 0.5. We're going to use it for our sigma also. And that's all we need here for our formula because our mu is going to be the 8.5. So let's plug those in. Open parentheses, 8.2 minus our mean, which is 8.5, our population mean supposedly, divided by the square root, or the standard deviation, which is 0.5, divided by the square root of n, which is 35. We're going to get that in our calculator, and I would use the parentheses. So we're going to do our open parentheses, 8.2 minus 8.5. Got to make sure you definitely put the subtraction in parentheses, because your calculator is definitely going to want to divide first. Divided by, I'm going to use parentheses here, 0.5 or 0.5 divided by the square root of the sample size, which was 35. Close parentheses there. You should end up with negative 3.549647. Let's go 2 decimal places. Negative 3.54, that 9 makes that 4 become a 5. So negative 3.54, we'll use that for our z. Negative 3.54. So now I'm sorry, 55. Rounded correctly. So we're going to put that in our curve, negative 3.55. Now that's in the critical region. Therefore, we reject the null hypothesis. We reject the null hypothesis. That's when you reject, when it's in the critical region. When your z value is in the critical region that you determine with your z sub 0. So if it's in the critical region, you reject the null hypothesis. That means in this case, if you reject the null, you're going to accept that claim. So we say there is enough evidence to support the claim that the mean workday for the firm's accountants is less than 8.5 hours. Section 7.2, page 388, try it yourself 10. The U.S. Department of Agriculture reports that the mean cost of raising a child from birth to age 2 in a rural area is $10,460. You believe this value is incorrect, so you select a random sample of 900 children age 2 and find the mean cost is $10,345 with a standard deviation of $1,540. At alpha equals 0.01, is there enough evidence to conclude that the mean cost is different from $10,460? So different from means it's going to be not equal to. So your claim is going to be mu is not equal to $10,460. Well, since it's not an equality, that's going to be the alternate hypothesis. CL for claim. And so the null hypothesis is going to be mu is equal to $10,460. So let's start by finding our critical values in our critical region. Since this is the not equal to, that means we're going to have a two-tailed test. So it's going to be left and right-tailed test. Here's our 0 in the middle. So we're going to use our table 5 to find that. We also need to know our alpha is 0.01. So when we go to table 5, we're going to go to alpha 0.01 for a two-tailed test. We're going to have a negative and a positive. So we're going to have alpha, two-tailed test, alpha 0.01. All the way down to the bottom, we get 2.576. So it's going to be a positive and a negative 2.576 for the negative and 2.576 for the positive. The next thing we're going to need is we're going to need our z. The formula for z is going to be x bar minus mu, all divided by the standard deviation divided by the square root of n. So we need all that information. Well, we've got our mu right here, the 10,460. So we need our x bar, and that's our sample mean. So the x bar is going to be 10,345. Our sample size, n, is going to be 900. And our sample standard deviation is 1,540. It's s, but we'll use it for sigma. So let's put all those in our formula, and we will have the x bar of 10,345 minus the mean of 10,460 divided by the standard deviation of 1,540 divided by the square root of our n, which is 900. And let's put that all in our calculator. So we're going to have our open parentheses, 10,345 minus 10,460, close parentheses, divided by, I'm going to put another parentheses there, the standard deviation, which is 1,540, divided by the square root of 900. Close that parentheses. And we'll end up with negative 2.240, or just negative 2.24. So that's going to be our z, negative 2.24. So it's pretty close to our critical value, our critical region, but it's not in there. So negative 2.24. So it's not in the critical region, then we do not reject, or we fail to reject the null hypothesis. Therefore, there is not enough evidence to support the claim that the mean cost of raising a child from birth to age 2 is different from 10,460. The claim is not supported because the null hypothesis is not rejected.